your slant asymptote into this mix. So, if you kindly graph this in your y equal, and see what this looks like. You're going to see this looks slightly different. The one nice thing about this, it also has a max and a min that we haven't been seeing. You'll actually see it hook back up or turn all the way down, and you'll be able to find your max and your min. So when you graph this, you're going to see something that goes like this, and you're going to see something that goes like this. So that's exactly what you see, right? Depending on how much your calculator shows you. You can almost spot your vertical, right? You can spot a vertical. We've got some kind of vertical coming down. But we don't really have a horizontal. We have what we call a slant. Do you see how this slants up? We have a slant asymptote that crosses through right through here. See it? We're going to find something that says, whoop, push my end up that way. Up, pull my end down this way. We're going to find a slant asymptote in there. And it's on the bottom of that thing. But let's walk through step by step. So, let's first start with your pieces. Let's look at your domain. Same as we did before. We cannot have a variable in the denominator without a domain restriction. Well, I shouldn't say that. We have to check for a domain restriction. So our restricted domain says get this 2 out of here. And again, we're not going to worry about your range until we get to that point. Now we're going to take your asymptotes. We're going to look at your vertical asymptote first. Vertical asymptotes are what parts? The zeros of where? Of x, but the denominator or the numerator? Denominator. Zeros of your denominator. So we look at x minus 2, and we know that that's an asymptote. So I know I'm going to start like this. Here's my one asymptote. Okay. Now, I look for my horizontal asymptote. What's the degree, the highest degree in the numerator? What's the highest degree in the denominator? 1. So, when the degree in the numerator is greater than the degree in the denominator, what does your chart say? There's none. Good, thank you. There are no horizontal asymptotes. Now, we have no horizontal. We have to check for a slant. A slant asymptote says this. If the degree in the numerator is exactly 1 more than the degree in the denominator, you have a slant asymptote. And this is what we're talking about. This is a 2, this is a 1. The numerator is exactly 1 more than the denominator. You'll never have a slant with a horizontal. That can't happen at the same time, right? Because if it says none when your degree is higher in the numerator, we then check to see if we have a slant. Now, a slant still has an equation of a line. So in order to find this equation, what we do is we synthetically divide this. Oh, but wait. It's much easier now. Let's set the denominator equal to 0. So a 0 is 2. 1, negative 2, 4. We bring this down. We multiply. We add this down. We multiply. We add this down. Now, if I'm doing x squared over x, what does this one start with? X. Isn't it always going to start with x to the 1?
Yes.
And isn't your equation of a line mx to the 1 plus b? So I'm always going to get an equation of a line. The nice part about this is, I don't really care about this remainder. Get rid of it. So I just now say y is equal to, and set this up. And it just so happens to be x this time, right? X plus 0, which is y equals x. Isn't that the equation of a line that goes right through here?
Yes, it does. Watch.
There it is, y equals x. So now I can make my graph a lot nicer. There's that part in here, right? And I can watch this come through in here. There is my piece in here. See it?
What is VA? What's that?
Vertical asymptote.
Oh, vertical.
Vertical asymptote.
And
So, what the one new thing we put in here was your slant asymptote. If your degree in your numerator is 1 more than your degree in the denominator, we're going to synthetically divide it. It's got to be y equals x something, because x2 over x1 gives us x1. So it's got to be y equals x something. Get rid of your remainder, and that's how easy your slant asymptote looks. Now, we can still find the rest of this. We can find your zeros. Let's find your zeros. Let's find your y-intercept. Set x equal to 0. Let's do it up here. 0, 0, 4. 0, negative 2. And we can always check to see, is this point the 0, negative 2? We can check that on our calculator for that point there. The zeros of your numerator, and I'm going to give you a break here. I got to take this, the numerator, because it couldn't be factored, and I got to use my quadratic formula on this. Now, do you think we have real zeros of your numerator? Looking at your graph, what kind of zeros would they be if I do your quadratic? They're going to be imaginary. And even if you didn't realize that, as soon as you do your quadratic and you get a negative under this thing, you can stop and say no real zeros. You can even look to this to tell you. Then across the x-axis, even if I use my quadratic or I compute the square, I'm going to get no real zeros. Now, this guy here, let's call this point A, is a minimum. Is it a relative or an absolute? Relative. It's a relative minimum. We're going to put it in your calculator, and we're going to find your relative minimum. This guy here, let's call this B, is a relative what? Max. We're going to put this in your calculator and find your maximum. Now from here, we can do your increasing from, let's take a look at your increasing, from negative infinity to that x value, which would be 0. My graph's just slightly off. And then increasing again from here, that x value. See it increasing? How about your decreasing? Where's your decreasing going? From this, just pretend it's over here at the 0. From 0 to where? Not 0 to where? What x value? 2. And then from where is it decreasing again? From 2 to what value? 4. Okay. Now, you got your max and your mins. Can you find your range now, since we have your max and your mins? Let's go look at your range. This is the highest I'm going to go to over here. What's this x value at B? I'm sorry, what's the y value at B? Negative 2. So we came from negative infinity to negative 2. And then, where again did we start? At 6. Good. At 6 to infinity. Okay? And now you should be able to also do your concavity. Here's the concave. This is a nice concave down. So what's concave down? What interval? Oh, okay. All right. On your homework, guys, do everything but number 2. Don't do number 2. You can't do number 2.